We turn now to a set of very powerful tests, which are the ratio and root tests. Um, so the ratio and root tests are both very powerful in the sense that, unlike the tests we've seen, the many of the tests that we've seen, you don't have to you don't have to guess the answer to use them. Recall that one of the things about using the direct comparison or limit comparison test is that it couldn't really tell you whether a series converged or diverged. You had to sort of guess whether it did, and then you could use the test to prove that it converged or diverged, and but you had to guess the correct series to compare it with. The ratio test can actually just give you an answer without you knowing anything at all. The weakness of the ratio test and the root test is that they might be inconclusive. They might actually fail to give you an answer. So let's see what the ratio test and root test are. First, the ratio test. So the ratio test says let sum of an, sorry, that sigma's a little bit squashed. Let sum of an be any series. Doesn't have to be a positive series, it can be any series. And we're going to calculate the limit of an plus 1 over an. So we're going to write two successive terms of the underlying sequence, one over the other, put an absolute value around it so that we're only considering the positive result, and then we're going to calculate that limit, and we're going to call that limit rho. This is the Greek letter rho, and it's spelled R-H-O, and it's like the R in Greek. So if rho is less than 1, then what we know about the series is that it converges absolutely. In other words, its positive term series converges, and therefore by the absolute convergence test, so does the regular series. If rho is greater than 1, then we say that the sum of an diverges. And if rho is equal to 1, then the test is inconclusive. We don't know anything about this series, and we don't know whether it converges or diverges, and the only way to determine whether it does is to use some other test. So that's the weakness in the ratio test, is we might get an inconclusive answer. One type of series in which you will always get an inconclusive answer with the ratio test is a p-series. You can't get an answer from the ratio test with a p-series, or really any series that's just the ratio of two polynomial functions. Doesn't give you an answer. So the root test it's kind of similar. It just asks us to calculate a different limit. So once again, if an is a series, then we do is we calculate the limit of the nth root of the absolute value of an. So we keep taking higher and higher roots. So like for example, we take the 1000th root of a 1000, the 1001th root of a 1001, etc. And that's what this expression means. And once again, we calculate rho, which is equal to that limit. If rho is less than 1, then sum of an converges absolutely. If it's greater than 1, then sum of an diverges. If it's equal to 1, then the test is inconclusive. And once again, we don't know anything. If we want to know something, we have to apply a different test. By the way, in both cases, to say that rho is greater than 1 also includes the possibility that rho is infinity. If either the ratio or root test limit gives you infinity, then we know that the series diverges.